because I had free time like today.
Huh?
But, like they
So,
would have given me the whole like picture.
shall I start from the one on the far left, or can you even tell?
Yeah, just start from the one on the far left, and
All
I'll
right,
do
we'll
some
just
finish.
go through them one by one, and if you've already done it, then we don't need to go through it. So,
Yeah, I have. Oh yeah, it did send actually. I wasn't sure if it was. Don't send all the way.
okay. So what are you saying?
Yeah, no, it's all right.
Where do we want to
So
start here?
we'll just start on number 3. I just kind of jumped around randomly. I don't really know why.
Okay. Well, I always let the student direct. So if you want to start on number three, let's start on number three.
So the
So,
R teacher was like, to get the radical out of the bottom, you want to multiply like by the same radical that's on the bottom for the top and bottom.
yeah, you want to rationalize the bottom. So in other
Yeah.
words, you want, hold on a second, let me take a picture of this. So I want to, in other words, I can multiply any fraction by the number one.
Yeah.
In this case, this is my number one.
hmm
Okay. And that turns the bottom into
27.
a rational number.
Yeah.
Now, what does it turn the top into? Well, let's see. I can simplify the top a little bit. In other words, I can simplify that.
Yeah.
That is 3 root 3, right?
Yeah.
So now the top is root 6 times 3 root 3.
And then it's 3 root 18.
Right.
Correct.
3 root 18 divided by 27. I can certainly do that like that. And now I
And it's
got root 18 divided by 9. I can
and
actually
then
simplify that a little bit. That's root 9 times root 2 divided by 9, which means
yeah.
we have 3 root 2 divided by 9, which means we have root 2 over 3 for the answer to that.
hmm
Might have been able to get there a little easier, but this method never goes wrong.
Yeah.
Let's just see. Let's just take a second here. If I were to write the numerator as root 2 times root 3, I can do that with root 6. And if I were to write the denominator as 3 root 3, correct?
hmm
Wow, look what happens. One step.
Yeah.
One step to get to that answer that it took me 1, 2, 3, 4, 5, 6, 7 steps. So, I guess the moral of the story is, and I didn't really know this when we first started this problem, but sometimes when you see common factors, it's correct to do it immediately. In other words, I wouldn't always separate that into root 2 times root 3,
hmm
but I would if I'm dividing by that which has a root 3 in it.
hmm
Then separating it is perfect because the root 3's cancel out and you have your answer immediately.
Yeah.
All right, let's look at 4. And let's kind of think about doing this the same shortcut way. So what can I turn that into before I rational? Well, hold on a second. This is a little different. I don't need to rationalize the bottom. What is the bottom?
isn't it just square root 4?
It's
Or
4.
yeah, it's just 4.
It's 2 times 2.
Yeah.
Now, so what I have is 3 root 20 over 4. But that can probably be, in other words, I can always simplify root 20. Because if I can divide a number by 4, I can simplify it. Because that 4 comes out as a 2.
Yeah.
Okay. So I can divide that by 4. So what do I get?
6 square root 5.
Simplify that.
Or 4, so then that's, and divide that by 2, so that's 3 square root 5 over 2.
Perfect. Now, number 5, pure rationalization problem. Tell me how to do it.
Yeah. So then we multiply by square root of 5 on the numerator and the denominator. 35. Then you have 4 square root of 5 over 5. And then that's
that's a relatively easy one.
yeah.
Okay, how about this one? What should I do before I go to rationalize everything?
I do not know.
What's the square root of 4?
Oh, just 2.
Okay. So let's at least do that. I don't know if it'll help, but it'll never hurt. Okay. Now, rationalize it. What am I going to multiply by?
Square root of 3. And that is 2 square root of
So that
3
gives me 2 square roots of 3 there. And what about the denominator?
over 15.
Yeah, and that is simplified. Can't be simplified anymore.
Yeah.
Okay. And I don't know if it would have been quite as quick had I rationalized it. It looks like it takes a little, I see all of this over here. There's no reason to get into all of that. In other words, simplify that square root of 4 to a 2 immediately, and I think it saves you a little bit of work.
Yeah.
About number 7.
Number 7 multiply by square root of 3 on both or numerator and denominator. So that's square root of 15 over 3.
Uh-huh.
And that's
simplified. Does square root of 15 simplify?
No.
No, it really doesn't. In other words, you can turn it into square root of 5 times square root of 3, which is what we had originally, but that doesn't help things. In other words, you've taken one term and turned it into 2, and that's never a simplification. There are certain numbers you cannot simplify. Square root of 10. It's true that that's square root of 5 times square root of 2, but that is not considered simplification. It's only simplification if you can pull a whole number out. Okay, how about 8? Okay, I can kind of see how you've done 8. So you get square root of 6 over 6.
Yeah. Then they start getting tougher after that.
Yeah. Okay, we'll look at the tougher ones here. Not really. I know that looks tougher, but it really isn't. What you just have to do is take one thing at a time. In other words, you take your numbers, and then you take the x variable, and then you take the y variable.
Yeah.
Okay? So let's start with our numbers.
Then you multiply both sides, your numerator and denominator by.
And let's not worry about rationalizing it yet. We can rationalize it in the end. But that's our numbers at the moment. Okay, let's go ahead and rationalize that now. Go ahead.
Then by square root of 5xy cubed on the other side.
Just doing the numbers. Forget the xy for the moment.
Okay, then you're multiplying by, by the square root of 5.
Correct?
Yeah.
Okay. Now let's do the letter x. What is the square root of x squared?
Here's x.
Now that's in the numerator. Now the denominator still has a square root of x in it, right?
Yeah.
Okay. Now let's do y. What's the numerator?
Square root of y.
Okay, here's how you do these. When I'm taking the square root of y cubed, that's the same as the square root of y squared times the square root of y, correct?
Yeah.
Which means it's the same as y root y.
Yeah.
Well, if it was y root y in the top, what is it in the bottom?
Y root y.
And now I can just cancel those. Okay.
Yeah.
So here's what I'm looking at this point. So this wouldn't be a bad answer, except for one problem. It's got a potentially irrational denominator.
Yeah.
So let's rationalize.
Then x, and you multiply the numerator and the denominator by square root of x.
Hold on a second. The way we're going to rationalize it is by multiplying top and bottom by what?
Square root of x.
Okay. What does that give you?
And on the top, that
What is
gives
all
you
of that equal to?
square root of.
You can combine these two because they're both square roots.
Yeah.
I have an x out front, so it's the square root of 15x. That's the numerator. What's the denominator?
20x.
Now, cancel that x with that x, and you got the square root of 15x over 20. And I can't really simplify that. And I have a rational denominator, so I'm in good shape. Okay? So any of these complicated problems that have a combination of numbers and variables, they're not really that hard. You just got to do them one at a time. In other words, you got to take the numbers, and then you got to take the first variable, and then the second variable. They could have 26 variables there. I wouldn't care. I would just go one variable at a time. Okay, let's go to number 10. Can't quite read your writing enough to see if you've done it right, so I'm just going to say let's start from scratch. Can we simplify that at all?
Yeah.
What can we pull out of there?
A y.
Okay, so let's do that. So what we really have, and I can't really simplify the numerator. There's nothing I can pull out of the numerator.
Yeah.
But I can pull that y out. So I have 3y root 10xy. There's still one y left. Okay. Now, before you rationalize this, let me show you a little trick. That is equal to the square root of 15xy over 10xy. You see why?
Yeah.
In other words, if I have the square root of x over y, I can separate that out into the square root of x over the square root of y, and I can go this direction also. And what I'm doing is going to the left.
Yeah.
Okay? And the beauty of doing that is now that xy cancels with that, and that whole thing becomes the square root of 3/2.
Yeah.
So I've got the square root, and I'm going to separate that again. Square root of 3 over the square root of 2. That's what that is. And I still have this 3y down here. Okay? So I've simplified it, but not totally. What last step do I have to do?
Multiply by the square root of 2.
Okay, that gives me square root of 6 there. And gives me 6y there. That's our answer.
Yeah.
Sure looks like this should be simplifiable because what it is 6 to the 1/2 divided by 6. Subtract the exponent, you get 6 to the minus 1/2. And that is actually a legitimate answer. It just happens to be 1 over square root of 6, which makes it an irrational denominator. So it doesn't work. But, you know, in all honesty to you, I think this rationalizing the denominator is not worthwhile doing.
Yeah.
In fact, when you get to trig, they will tell you do not rationalize the denominator because there are so many instances where you're better off if you don't rationalize it.
Yeah.
And so it's a little bit of a tricky thing. It's just math convention that they rationalize the denominator. I don't think there's anything fundamental in math that forces you to do that. But until they change the rules, then we got to do that.
Yeah.
All right, so this one you multiply top and bottom by 8a, but I don't see any answer.
I don't really know where to go from here.
So multiply that by those two terms. What do you get?
3
3 square root of 8a. Got to multiply it by both terms. In other words, you got to also multiply it by that term.
and square root of 24a squared, but then you said it's
Let's go
24a.
ahead and let's work from left to right. Okay? There's this 3 right here. Let's put it in there first.
Yeah.
And now 8a times that is 24a. You don't have to simplify right away. You can always wait to the end to simplify. In fact, I think I prefer it. And now, because it's so easy to make a mistake if you simplify along the way. All right, now, that clearly becomes 32a.
Yeah.
And that could be an answer. Let's look at that for a minute. We have a rational denominator. There's no way we're getting that a to cancel out with any of those a's. The only thing is we can turn this into 4 times root 6. And we can turn that into 4 times root 2. So we should simplify that. So let's turn the 8 into 2 root 2. So that's this part here. Minus, that 24 comes out as a 2 root 6. 2 times 3 is, well, I'll write it like I did the first one. And what's left is 6a. And that gives us 6 root 2a minus 6 root 6a, and we're dividing the whole thing by 32a, correct?
Yeah.
And I think we could actually simplify that. Let me show, oh man. You happen to remember what I had?
I think it was 6 square root of 2a minus 6 square root of 6a over something.
This was 6a
I believe so.
over 32a.
Yeah.
Yeah. Now here's why I can simplify it. Because I can write 6a as square root of 2a times square root of 3. And that gives me, you'll see here, I think we can simplify this. So here's what I'm going to do. I'm going to write it like this. And I pull the 2a out of there, and I still have a square root of 3. In other words, those have to multiply together to give you 6a. Okay. Now, notice what I can do. I can actually factor out a greatest common factor. So let's do it. See if it helps. Sometimes this doesn't really help much, but sometimes it does. So that's 1 minus root 3 all over 32a. Well, I can certainly make that a 3 and that a 16. And I don't believe I can take it down any further, but that's not bad. And I'll bet you that's the answer, and I'll bet you very few people would find that answer. And in fact, I can even distribute. No, I don't want to distribute. I went to all the trouble of factoring it, so I'll leave it factored. Yeah, there's multiple answers here that are all correct. That's correct, but also if I distribute the top, still correct. The original one, no, 6 over 32 would not have been correct because you can always simplify that. Yeah. If you can simplify it, then they're going to deduct points if you don't do it. And some of these are tough to simplify, others are not. Let's see, which one was that? That was this 11. Let's do 12. The one thing I can see right off the get-go is what can I do with that? Might as well do it. What? I'm not understanding what you're saying.
The numerator would be 3n squared plus 2n. Square root
Not plus 2n, plus n root 2. In other words, I can't take the root 2 out, but I can certainly pull an n out. Now what?
Multiply the numerator by square root of 10 and then distribute it to the
Okay, what's my numerator become?
you have 3n squared times 10 and
Hold on. I'm not hearing you. You need to put your voice closer to your mic.
it would be like, can you
Ah,
hear me?
much better. Huge difference.
Yeah. It would be, wouldn't you just put it as like 3n squared square root of 10n plus um just 2
Remember, you
n
don't have to do the whole thing at once. You can just multiply that times that and simplify it later.
n square roots of 20n.
Perfect. Now that does simplify, but let's not worry about it for the moment. What's the denominator?
Just 10n.
All right. Now this square root of 20 becomes 2 root 5.
Yeah.
And that n, I should have written it like that. Wow.
Yeah.
Boy, they really have tested you here. There's so much simplification to be done. Okay, I'm going to start writing in the upper left here because I need room.
Okay.
This is high-level algebra. So this, I can take a 2 out. And what's left under there is 5 root n. With me?
Yeah.
Now, might be worth turning that into root 5n times root 2.
Yeah.
Because then I can factor a root 5n out. So let's rewrite that. 3n squared times, now be very careful here. Make sure that when you separate this out, you don't make the mistake of making that 2 a whole number. In other words, these two numbers have to multiply together to 10n, square root of 10n.
Yeah.
Okay, so now we have this. Just working with the numerator, I'm going to take a greatest common factor out of that. Well, the greatest common factor is that, n root 5n. I can take one out from this term, and I can take one out from that term. You see how?
Yeah.
Okay, so I'm going to take an n root 5n
Times 3n plus 2.
root 2. There's still that root 2. Nothing happened to that.
Yeah. 3 root 2. 3n root 2 plus 2.
Perfect. Now, we still have in the denominator 10n. And that's why you factor these things, because sometimes you discover very nice things, like those n's now cancel.
Yeah.
And that's an acceptable answer, assuming that I haven't made a mistake. There's so many algebra steps here that it is extremely easy to make a mistake.
Yeah.
Now, do I need to do anything with this numerator? Say no. When you get far enough in math, you kind of realize that factored answers are better than unfactored or than multiplied out. When you leave it in factored form, you're ready for the next step. Whatever they got in mind for this answer, you're ready for it. Whereas if I were to multiply this out, then I'd have to probably factor it. So leave it factored. If And I can't see anything else there that we can do.
Mm-hmm.
So, okay. Well, you're right. They do get tougher here, don't they?
Yeah, a lot more steps.
Let's see. That was 12.
Then there's
Oh, I have another
switch over to multiplication, which is like the third or fourth one.
Okay.
It's like halfway.
Here,
I feel like I
let
have
me
that
take a
one.
quick look. You tell me if this is the one you want to do.
Okay.
Multiply?
Yeah. Yeah.
Okay. I think I can actually do it without downloading the file. Yeah. As long as I can zoom in on it. I don't have to rotate it.
Yeah. So then, for these, don't you just do like the number two, just be the square root of 50 and then 5 times.
This looks like a technique that somebody taught you. I'm
Yeah.
not sure I like it.
I just because like whenever I'm factoring, I just like forget to take out the two pairs. I make sure to like to write it all out so I don't mess up.
Problem is 3 times. So what you did was, see, I'm not sure that's even right. Does that multiply to 72? I don't think so.
Yeah.
9 times 6 is 54. That's 54. And that times that is 72. Which you've got down there. And you can turn it into that. So the first one is correct. It's just you don't really need this step. You can go straight to this step here.
Yeah.
In other words, multiply the 12 times the 6 and you got square root of 72. And now you've simplified that into 6 root 2.
Yeah.
Multiplied by 3 is 18 root 2. So you've done that one perfect, and you don't need any of this stuff here. You need everything
Yeah.
else. But you need to go there and then there, like that.
Mhm.
Okay, what about 2? Let's do that same process.
And it'd be the square root of 50 and then you factor out a 5 and 5 squared is a 2.
Hold on. 5 squared roots of 2, it's 5 squared roots of 10.
Oh, yeah.
Does that help?
Yeah.
Not really, because I can't pull out a whole number yet. So I don't want to factor it that way. How do I want to factor it? What are better factors for 50? Remember, when you're looking for the factor, you want one of them to be a perfect square number.
2 and 25.
Yeah, that's much better. And now
And
that becomes a whole number.
5 squared is a 2.
And there's your answer.
Yeah.
Okay, number 3 you got. Number 4. You know, I see all this over here, and again, that's not going to be your shortest method. Your shortest method is going to be to multiply those two numbers together. What's 5 times 20?
100. No. Yeah.
What's the square root of 100?
10.
2 steps. All this is, don't need to do it. In other words, I guess what I'm going to suggest is that your first step, at least in these first 4 problems, the best first step is to multiply that times that, multiply that times that, multiply that times that, multiply that times that.
Yeah.
Number 5.
So then that would be 4 square roots of 30, 45. 1 squared is 45. And then you can factor out 3, so that'd be
Hold
12.
on. Can you factor out what?
That's 3.
Okay.
And that'd be 12 squared, so 5.
Correct. Okay. Number 6. Here, let me scroll down a little bit. Okay. Now, the one thing you want to recognize right away is we got the square root of 20 times square root of 20. What is that? 20. Square root of x times square root of x is x, no matter what x is. So again, I don't even need to take it up to square root of 400. That just complicates it. Because then I got to figure out what the square root of 400 is. So what I can immediately say here is I got 20, then I got the square root of x cubed, right?
Yeah, and then you can factor out
What's that equal to?
20x squared to x.
Yeah, again, we got all this stuff going on here that's totally unnecessary. And it's probably slowing you down a little bit. It almost has to be. So let's apply that reasoning to this. In other words, don't simplify first, multiply first, and then simplify.
150 n to the 5th.
Now let's deal with the 150. What's a factor of 150 that's a perfect square number?
Ooh,
Think of your perfect square numbers.
25.
Perfect. So it's 25 times 6. That means the 5 comes out there, leaving root 6. That's the square root of 150. Now, what
And
can you do with the n to the 5th?
you can factor out n squared and then leaving one n inside.
And normally you want to write this with the,
Yeah, 5n squared.
but there's your answer right there.
Yeah.
Which one was that? That was 7? Yeah,
Number 5. Or yeah, no, that was number 7.
7. Okay, well, let's just look at your, again, I don't think we want to see all that stuff over there.
Yeah.
So if we just do the multiplication first, what do we get? We get this. Now the 54. That's the only thing. Everything else is easy. Square root of 54. Start thinking of factors. Are any of them perfect square numbers?
9.
9 and 6.
Yeah, 9 and 6.
Okay, so the 9 comes out as a 3. 3 times 4 is 12. You've left behind the 6. What's the a to the 4th come out as?
A squared.
There's your answer. So usually simplifying these radicals is really all about knowing your perfect square numbers.
Yeah.
Okay, how about number 9?
Negative 18 squared is 49 out of the 5th.
Simplify.
Then you can factor out a 7, and you can also get out r squared, leaving 1 on the side. So it's
So
negative.
that's 126. When I factor out the 7, and I got r squared there, And there's the only one remaining.
Yeah.
Okay. Number 10. This is a much simpler way to do it. Don't you agree?
Yeah. And it's
Except,
-4.
yeah, now we're going to run into a little bit of a problem here. And I'll show you why there may be an advantage in simplifying this one first. But let's just do it the way we've been doing it and see what problems present themselves.
-4 square roots of 196x to the 4th.
Now, see, it's a little tougher to break down 196, isn't it?
Yeah.
So, to eliminate that, let's simplify the 28x first, because a 4 comes out of that, leaving behind a square root of 7. Okay,
Yeah.
so that actually becomes this. And now, the problem becomes much easier. That's multiplied, so a 7 is going to come out. Square root of 7 times square root of 7 is 7 times -8. That becomes -56. And square root of x to the 4th is what?
X squared.
So notice how much easier it was. We didn't have to deal with that square root of 196. And I suppose if you have a calculator, it doesn't matter much, but this does kind of show you that sometimes it's worth simplifying first, sometimes it's worth waiting. If we simplify first here, we make the problem a little easier. We can
Wait,
do
what
the
if
whole problem without a calculator. What?
what if -8 be -16 because you factored out a 4 from the 28, and then you had to
We
multiply it?
actually, that 4 turned into a 2. In other words, you're right. 28 is 4 times 7.
Oh yeah, yeah,
When you
yeah,
pull a 4 out, it's a 2. And then it's
yeah,
2 times -4. So that's how I got the -8,
yeah,
leaving behind the square root of 7.
yeah.
And the only reason I saw to do that was because I could see I was going to end up with that situation. In other words, if you can simplify that and get the same numbers you have over there, it's going to be simpler to simplify it first. Okay. Notice up here we couldn't do that. Simplifying it first wouldn't really help. You'd have square root of 6 times square, I guess you'd have 9 times square root of 2, but square root of 2 is not square root of 3. So not such a big advantage with a problem like that. But a problem like number 10, there was a huge advantage in simplifying first.
Yeah. Number 11.
Number 11. Well, you had a lot of problems. You were ready for bear tonight. You were ready for a 2-hour session, weren't you?
Yeah. For these, don't you just distribute the the square root of 3 to the
Yeah.
5?
Just do a couple of them. You can do them real quick.
Yeah. So for 11, it'd be 5 square root of 3 plus 3.
12.
Isn't that all the way? Oh, yeah, yeah. So number 12, then you would be 2 square roots of 30 plus 2, or plus 4 square roots of 5.
Right. Now, 30 is the square root of 6 times the square root of 5. I don't know that you necessarily have to do this step. The only reason I might do it is because now I can factor 2 square root of 5 out, giving me square root of 6 plus 2. And I don't know that that answer is any better than that answer. Or rather, that answer, that first one right there, I believe would be the answer you would want.
Yeah.
You could do what I did here, and it does allow you to factor it, but they didn't really say factor it. They said come up with the answer, and factoring's not the same as simplifying. Remember, you don't necessarily have to factor. You do have to always simplify.
Yeah.
Or what I call simplify. Okay, so what do we got on 13?
It'd be -6 square root of 3 plus.
No?
Oh, it'd be minus because it's negative, right? Yeah. And then.
Now the best way to do this is just go ahead and do the multiplication, because we're not looking at big numbers. Square root
Minus
of 18 is not going to be difficult to simplify.
yeah, minus 3 squared is 18, and 18 you can pull out a 3, and so that's -6 square root of 3 minus.
Hold on. You can pull out a 3, but it's got to multiply by the 3.
Yeah, so minus 9 square roots of 2.
That's right. And you want me to check your answer here? Let's see. It looks like you got minus 5 root 30 plus root 18, which is 3 root 2. And, you know, that's correct. That actually does not simplify.
Yeah.
It doesn't. You can separate it into this, this, and this, all prime numbers, none of which produce a whole number. And that certainly doesn't really do any good. Even though we do have this 1 square root of 2 over here, we'd be able to factor out a square root of 2. So again, it would allow us to factor it, but that's the only advantage in breaking that down. Is the only time you really want to do that is if you can simplify it. And like I said, there's a difference between factoring and simplifying.
Yeah.
That was the third page. Which one? We got 10 minutes. I have no wiggle room tonight because I have an 8 o'clock.
And the fourth one. And it's just more complex versions of that.
Okay.
I haven't started much on these.
More complex means only one thing. More steps. Not harder. Just more steps.
Yeah.
So let's just go through them.
Number 19. Is that a 3y? Is that what that says?
It's a V, I believe.
Oh, well. 18v squared, 18v plus squared and 30v. And then 18 you can factor out a 3, and then it leaves 2v. So 3 squared is a 2v plus in the 30. Yeah, it can't be factored, right?
You're right. It can't be simplified.
Yeah.
Now you could factor it into 15 and 2, and then you could factor out a square root of 2v, but that's all you would be able to do. So I don't know why that would necessarily be advantageous. I think this would be the right answer.
Yeah.
Yeah, don't worry about, Tell me what the answer to this is.
wouldn't that be 7 square roots of 2b?
Yeah. So that's the only time I might do something like that. In other words, if that turned in other words, notice what that turns into. So now you got a square root of 2v there, a square root of 2v there. So factor out the square root of 2v, and you're left with 3 plus root 15. Again, a factored answer, but not necessarily a simpler answer.
Yeah.
So again, let's go with that. This definitely over this. The first one can definitely be simplified. This is not really a simplification of that. It's just factored. That's all it is.
Yeah. And we can do like 25 because that one looks hard.
Okay.
Oh, man.
It's not really. It's just a binomial. In other words, you're going to FOIL it, right?
And the front would be negative 20 squared. No, negative 20 times 2x. So that'd be negative 40x. And outside would be...
That's times that. Yeah, okay, now the outside is what?
Is 5 square roots of 10x.
Plus sign. You got to say plus.
Yeah, plus 5
roots of 10x. Okay, next term.
Inside is the negative 4 square roots of 10x.
That's good. Okay.
Plus the square root of 25x.
Which is 5 square root of x.
Yeah.
Now, we can combine those. As typically, whenever you do a binomial times a binomial using FOIL, you generally can combine the middle two terms.
And then that is square root of 10x. Just, yeah. Plus square root of 10x plus 5 square root of x.
Now.
Woo, that was a doozy.
Well, we're not quite done. Or are we? Maybe. In other words, again, I got a square root of x there and I got a square root of x there. But for me to pull them out, I'd have to factor it out, and it's not really worth it. So there's nothing wrong with that as an answer.
Yeah. Oh.
Got 5 minutes. I'll let you pick. You want to try 26?
Yeah, we just try 26.
Okay.
And the first term in the FOIL would be negative 3 times 3k, so that'd be negative 9k. And then,
okay, hold on, let me start again. Negative 9k, okay. That's that times that.
And outside would be 15 square roots of 3k, so plus 15 square roots of 3k. And then inside would be 4 plus 4 square roots of 3k. And the last would be minus 20.
Simplify.
And then that would be, so negative 9k plus 19 square roots of 3k minus 20.
There you go.
Alrighty.
Does that take care of you tonight, Blake, or you want to do another problem off that other page?
No, I'm feeling pretty good on those, actually.
What's that?
I'm feeling pretty good on those now.
Yeah, no, it looks like you're understanding it really good.
Yeah.
Okay.
Oh
Cool.
yeah, and then I also got a 97 on my last quiz on the last stuff that we went over.
Good for you.
That's cool.
That is a
Yeah, thank you.
score for sure. Yeah. All right. Well, Blake, I will talk to you next time.
Alrighty. Thank you. Have a nice rest of your night.
You too.